I am Dr. Pravina Piste, Professor in Chemistry at Raj Shikshan Sanstha's Arts, Science and Commerce College, Ramannagar, Burli. Now today we will study here the Organic Chemistry, paper 10th for the BSc part 3rd. The name of the topic is Infrared Spectroscopy. Our inspiration, founder of Raj Shikshan Sanstha, Padma Bhushan, Dr. Karmveer Bhaurao Patel. This video is for educational purpose only, no copyright infringement. This copyright belongs to its rightful owner. Credit goes to respective video music composers and singers. The pictures, images, names and or photographs shown and or depicted in this video tutorial are for representation purpose for ease of understanding the subject. The pictures, images, names and or photographs used are for educational purposes only. Now we will study here the infrared spectroscopy. Now last video that we have studied the characteristics of the infrared absorption of the alcohols and ethers. Now we will see here the characteristics of the infrared absorption of the carbonyl compounds, and carbonyl compounds is nothing but aldehydes and ketones. The principal infrared absorption of aldehydes and ketones is the carbonyl stretching absorption, a strong absorption that occurs in the vicinity of 1700 per centimeter. In fact, this is one of the most important of all infrared absorption because the carbonyl bond is stronger than the alkyl bond. The stretching frequency of the carbonyl bond is greater. The position of the carbonyl stretching absorption varies predictably for different types of the carbonyl compounds. It generally occurs at 710 to 715 per centimeter. Now see here, it appears at 710 or 715 per centimeter for the simple ketones and at 720 to 725 for the simple aldehyde. The carbonyl absorption is clearly evident in the IR spectrum of butyraldehyde. The stretching absorption of the carbonyl hydrogen bond of the aldehyde near observed at the 710 per centimeter and is the another characteristics absorption. However, the NMR spectroscopy provides a more reliable way to diagnose the presence of this type of the hydrogen. The compounds in which the carbonyl group is conjugated with the aromatic rings, double bonds or the triple bonds have the lower carbonyl stretching frequencies than unconjugated carbonyl compounds. The carbon-carbon double bond stretching frequencies are also lower in conjugated molecules. These effects can be explained by the resonance structures of the compounds. Because of the carbonyl as well as CO double bond C bonds have the some single bond characters as indicated in the resonating structures. They are somewhat weaker than the ordinary double bonds and therefore absorb in the IR at the lower frequency. Now in cyclic ketones with the rings containing the fewer than the 6 carbons, the carbonyl absorption frequency increases significantly as the ring size is decreases. Now see here the saturated aldehydes and ketone shows the absorption at the 725 and 715 per centimeter. The presence of the aldehyde group is confirmed by the occurrence of the additional bands at the 2820 to 720 per centimeter. These bands arise due to the CS stretching of the CHO group. The carbonyl stretching frequency is affected by inductive as well as the resonance effect. Now aldehyde shows the prominent absorption band in the IR spectrum, that is at the 720, then 2720 and 2820 per centimeter. The ketone shows the 715 per centimeter, while the aromatic aldehyde shows the carbonyl stretching, the frequency at the 1700 per centimeter. The ketones and the aromatic aldehyde absorbs at the lower frequency. This is because of their electron releasing capacity, which increases the single bond character of a carbonyl group due to the polar nature of the carbonyl group. In aromatic aldehyde, the benzene nucleus acts as the electron releasing group, and the carbonyl group frequency in case of the acids is observed at the about the 730 per centimeter, while the OH frequency broadband is located at 3300 to 2700 per centimeter. The carbonyl group frequency in case of the ester is higher than that of the ketones, and it shows the absorption at the 1735 to 1750 per centimeter. In addition to the CO stretch of an ester occurs at 1180 to 1200 per centimeter. Now see how looks the absorption band of the CO stretching at the near about the 1700 per centimeter. Now see the IR spectrum of 2-hexanone. Now see the arrow is showing the CH stretching due to the presence of the CH3 as well as the CH2, that is the methylene group. And then here at the 716 is due to the presence of the ketonic group in the compound, that is the CO stretch. And in the fingerprint region you will observe here the CH bending, rocking as well as the CO stretching in the fingerprint region. Now this is of the IR spectrum of 2-hexanone. Now next one is the IR spectrum of 2-butanone. Now there is a overtone band which is observed before the CH stretching due to the CO. The CH stretching is observed at the 2982, while the CO stretching is observed at the 715, indicates the presence of the ketonic group. There is also the 1376, the CH bending, then 1175, this is due to the CO stretching. The band is observed and indicates that the presence of the ketone, that it is of the 2-butanone. Now the IR spectrum of ethyl methyl ketone. Now in this the CH stretch is observed at the 2991, while the CO stretching is observed at the 715, indicates the presence of the ketone group, that is it is of the ethyl methyl ketone. Now this is the IR spectrum of the benzaldehyde, aromatic aldehyde. It gives the CH sp2, that is aromatic CH, and it gives at the 3200 to 3300, while this showing the aldehyde CH, which is observed at the 2720 to the 2820. The two peaks is observed due to the aldehydes. The CO stretching is observed due to the ketonic presence of the ketonic group, and the arrow which indicates the aromatic ring, the C double bond C, indicates the presence of the aromatic ring. Now see the IR spectrum of the butyl aldehyde. The CS stretching due to the alkyl group observed at the 2976. The CS stretching due to the aldehyde observed at the 2827 and the 2700 to 25 indicates the presence of the aldehyde functional group along with the ketonic group at the 1731 indicates the presence of the aldehyde functional group. Then next one is the IR spectrum of the 1-butanol. This is also the similar as that of 1. It is the CH is observed due to the alkyl group, presence of the alkyl group. The two peaks which is observed, that is at the 2725, 2827 due to the CH stretch in the aldehyde, and 1731 due to the CO stretching. Now this is the typical infrared absorption values for various types of the bonds. Now this is a collection of the sorts, the carbonyl stretch around the 1700 per centimeter, the aldehydes, then ketones, esters and carboxylic acids, all this functional group containing the carbonyl group. In aldehyde, the CO stretching which is observed at the 1740 to 1720 per centimeter. In ketone, it is observed at the 1750 to 1715 per centimeter. In ester, it is observed at the 1750 to 1735, while in the carboxylic acid, it is observed at 1725 to 1700 due to the hydrogen bonding, the frequency it is and the decreases. Now for the next video, visit the Ray Shikshan Sanstha's YouTube channel, Ray Knowledge Bank. Now thank you very much for watching this video. Thank you.